Welcome to our podcast. Today topic is cloud storage provide benchmark. Myself Sakshi, here guest is Riddhi.
Thank you for this opportunity.
Let's start for the podcast. Why these providers only, why others are not allowed?
Great question. AWS S3 and Google's cloud storage together account for somewhere north of 55% of all enterprise object storage as of 2025. They are the two most feature complete, globally distributed and battle tested platform, and they are the two that virtually every enterprise achieved has to choose between at some points. R2 and B2 are excellent for specific cost sensitive use cases.
What is S3?
Amazon S3 simple storage service launched in 2006. It was literally the first commercial available object storage service at scale. Today it stores more than 3050 uh, trillion object. It operates out of 33 geographic regions with 105 availability zones. S3 offers 11 storage classes from S3 standard for frequently accessed data all the way down to S3 deep archive for cold storage that you might access once a year. The key promise is 11 nines of durability.
And what is the Google Cloud Storage?
Google Cloud Storage launched in 2010. It builds on the same infrastructure Google uses internally for YouTube, search, and Gmail. Google Cloud Storage operate in 40 regions globally. It has four primary storage classes standard. Cold line and archive. What difference Google Cloud Storage architecture is global namespace. A single bucket can serve data from the edge closer to without having to replace manually. And like S3, it promises 11 lines of durability. The underlying replication engine is Google distributed file system, which is the original Google file system.
But where we do the real difference emergency that we are going to spend the next 110 minutes unpackable, but the break. First week break, what did the taste of the environment look like?
Absolutely critical point. Here is our setup. We ran test over 6 weeks. AWS and Google Cloud Storage, those are co-located in northern plus regions. On AWS, those are the compute layer was identical. AWS and Google Cloud Storage, both providers with 100 Gbps network adapter. We used the same 100 GBE on link on both sides, so network was not bottleneck.
Okay, what object type did you test?
We tested 5 object size buckets, 4 KB representing metadata, heavy workloads, 64 KB representing small media thumbnails, 1 MB representing typical application assist, 128 MB representing large data set, uh, and 5 GB representing video files and data lake exports. Each size bucket got 1 lakh operation samples for puts, gets, and deletes. We used S3 side and the Google Cloud Storage parallel composite upload feature with Google Cloud Storage side to ensure we were using each provider's optimal tooling.
That is really important by pointer using the tool per provider a lot benchmark just used to AWS and DSK for the both wonder by the GC it look exactly. What about the regions inter-region versus the cross-region transfer?
All our primary latency and throughput benchmarks are intra-region. Compute in the same region as the bucket. We have separate section on the cross-region both for performance and for pricing implications, which as you will see this we also tested both HTTP and HTTP 1 and HTTP 2 since Google Cloud Storage has excellent HTTP 2 support for a while and AWS S3 added it relatively recently.
We so definitely it is. I want to be a listener who are the not famous. Open the source serial and the faster than the official AWS. We will show the any other methodology creating before we get into the results.
Two important ones. First, all tests used server-side inscriptions. AWS and Google managed keys on Google Cloud Storage. Some older benchmarks keep inscription to inflate throughput numbers, which is not realistic for any production workload. Second, we did not test S3 Express, one zone, or Google Cloud Storage dual region. Those are special products with different pricing and durability. Uh, we will mention them, but they are not part more core comparison.
The perfectly kind of this entirely honestly writer that matrix methodology is a sound. Let we go for the numbers. It is the one people in the come in the raw intensely and walk us from the true single trade get it lengthly first.
Starting with the most basic metric, time to first byte, single uh, GET intra-region is for a 4 KB object. AWS S3 clocked in median on 11 ms with a 9 P99 of 28 ms. Google Cloud Storage came in at 9 ms media. That's meaningful advantage for Google Cloud Storage at small object size, about 18% faster at median and 21% faster at the 99th percentile.
Interesting that whole at the layer object size.
It narrows at 1 MB S3 is 18 ms median versus Google Cloud Storage at 17 ms, essentially a tie. At 128 MB, S3 actually pulls ahead 310 ms versus Google Cloud Storage at 314 ms. The pattern we see is Google Cloud Storage has latency advantage at small object due to the connection infrastructure, but transfer acceleration and edge optimization kicks in at larger size.
Now take to the 512 currency result.
This is where it gets really interesting. At 512 concurrent threads, both services are clearly network bound before hitting any API limit. For 1 MB object, S3 achieved a sustainable GET throughput of 47.2 GB aggregates across our 100 Gbps interface. Google Cloud Storage achieved a 49.8 GB. Both are impressive. They both link, but Google Cloud Storage is sequentially slightly more efficiency out of HTTP to multiplexing.
Okay, what about the PUT throughput, right? And often bottleneck in the data pipelines.
Put PUT throughput is where S3 has traditionally had an edge due to its multiple upload infrastructure being more mature. In our test at 128 MB object size with 512 threads, S3 throughput was 38.4 GB versus Google Cloud Storage at 350.1 GB, about 9% advantage for S3. However, Google Cloud Storage parallel composite upload narrow this significantly. With composite uploads enable of 5 GB object, Google Cloud Storage achieved a 52.3 GB versus and flips the result at very large size.
Let is let this access heals of the object storage sometimes that cause the real plan in the data lack of workloads.
Great point. Operations on S3 are limited to 1000 objects per API call and have been significantly slower than Google Cloud Storage. In our test, listing a bucket with 10 million objects, S3 took up approximately 8.9 minute using list object with maximum parallelism. S3 has introduced S3 inventory and S3 metadata, which are solution, but for real time listing, Google Cloud wins the category.
What about the delete true up bucket delete are the critical data relation of the cost management workflow?
S3 supports batch detects of uh, up to 1,000 objects per request. Google Cloud Storage also does batch detects, but with slightly slower per request limits. Uh, in practice, 5012 concurrency, S3 achieved 94,000 deletes per second, and Google Cloud Storage at 81,000 deletes per second. S3 wins here by about 16%.
Let us zoom out. If I am VP of the engineering listening to this, what will the take away from the performance section?
Three things. One, for small objective workloads, metadata, APIs, thumbnail, service, event driven uh, has a meaningful latency advantage. Second, for raw bulk throughput at large scale, they are essentially equivalent within measurement noise when both are properly tuned. Three, S3 has the edge on high concurrency bulk operation like deletes, while Google Cloud Storage has edge on large sequential uploads. The real performance difference is not raw speed, its operational characteristics around these numbers, which we will get into text.
One thing I want to flag from the we move on till the potential of the P99 to the P999 number. Can we pick those?
This is really important for SLA sensitive workloads. Uh, uh, Lower tail latency for small object for 4 KB gates. Google Cloud Storage P9 999 was 68 ms versus S3 at 94 ms. This might not matter for batch pipelines, but it absolutely matter if you are serving object in the critical path. For a user facing application, Google Cloud Storage tail latency at small size in best in class.
This is the consider of GCH advantage across the border on the small object latency. What is the architecture regions?
Google networking layer and its edge optimized for low latency small object servicing. They benefit from the same infrastructure Google built for search and maps servicing, where millions of tiny responses per second with ultra low latency is the entire job. S3 was originally optimized for durability and throughput. Amazon has instead heavily in catching up, and the gap has narrowed significantly since 2020, but small size Google Cloud Storage still has the edge.
What I agree in the most important characteristic for the enterprise story, durable and available both service advanced 11.9 durable, but what does that actually mean and are the three meaningful difference?
Uh, Let's start with durability. 11 nines means that if you are store 10 million object for 10,000 years, you had expect to lose one object. Both S3 standard and Google Cloud Storage standard achieve tiny by stripping data across a minimum of three geographically separated availability zones within a region. The ensured cooling schemes are different. AWS uses read cooling with while Google uses variant of internal replication, but and guarantee is equivalent.
Where do the differences emerge in the durability?
Two areas. First, cross-region replication. S3 cross-region replication requires explicit configuration. You set up replication rules. It's eventually consist and you pay for your replication and Google Cloud Storage, dual region and multi-region buckets are first class, where data is near replicated before wire is acknowledged. Google Cloud Storage multi-region buckets guaranteed 11 nines durability and 99.95% availability, higher than the standard 99.9%. Second, S3 has a concept called S3 object lock, which provides warm write once read many. It means Google Cloud Storage has a bucket lock for uh, both are solid, but enterprise uh, tooling around S3 object lock is more mature.
Let the availability of the HLA, these are the actual contract graduate, not in the theoretical maximum.
Critical distinctions, both S3 standard and Google Cloud Storage standard offer 99.9% monthly. That's 43.8 minutes of downtime per month. If availability drops below 99%, you get a 25% service credit. Below 95%, you get 100% credit back. The real question is historical track record.
Okay, this is how does the CES compare historical.
Both services have had significant incident. Uh, it took down S3, and because so much of internet release on S3, it effectively took down a larger portion of the internet for about 4 years. That incident actually excel the adoption of multi-region. The industry, Google Cloud Storage has had its own incidents, but they have generally been shorter in duration. I want to careful about drawing a conclusion from handful or includes over through both are genuinely reliable services.
Thank you, where we will Here we will got our the consumption model strong and the initial consider is a big deal for the central workload.
Both read after write and list after write operations. So today they have equivalent on this dimension, but Google Cloud Storage had 4 year head start, which matter for system that were designed before. This is significantly differentiator. Thank
Thank
you.
you.